Chapter 7, Section 2. Now we're going to multiply monomials. And just like fractions, in 7-1, when we were adding and subtracting, we had to have like terms. When we multiply, we do not need to have like terms. And so what we're going to be doing is multiplying some binomials times some trinomials and binomials times binomials. And so let's take a look at these. So let's say I had a couple of binomials. Let's go with x plus 4 times x minus 2. Okay, you'll notice here that there's nothing separating these parentheses this time. There's no addition sign, there's no subtraction sign like there was in the first section. And so that's going to signify multiplication here. So I'm going to teach you two methods. I'm going to teach you the distributive property method and also the FOIL method. There is a third method called the table method, but we're not going to focus on that as much. And so if you see that in the instructions in the book to use the table method, then you're welcome to use one of the other two, either the FOIL or the distributive property. So here's what I'm going to do. I'm going to take this first binomial, and I'm going to take the x out of there, and I'm going to multiply it times the second binomial. And then I'm going to take the 4 out of there, and I'm going to multiply it times the second binomial. And so again, we're doing distributive property. So we'll draw our stupid arrows. And x times x, that gives me x to the second power, back from chapter 6. And then x times negative 2, that gives me negative 2x. Draw our stupid arrows again on the bottom one. And so 4 times x, that gives me 4x. And then 4 times negative 2, that's going to give me negative 8. So now, just like we did in the last section, now it's an addition problem. So I get the like terms together. And I combine them. Okay, so nothing to put with that x squared. I have negative 2x, and then that's a positive 4x because it doesn't have a sign on it. So negative 2x plus 4x, that's going to be positive 2x. And then the negative 8 has nothing to go with. And so we end up with a product of x squared plus 2x minus 8. And that is the distributive property method. So now I'm going to teach you the same problem. So we've got x plus 4, what was that, times x minus 2. This one I use more commonly. Again, completely up to you which one you like better. This is called the FOIL method. FOIL as in the silvery, shiny stuff in your kitchen. And that's going to stand for first, outside, inside, and last. So I'm going to multiply the first term times the first term, and I am going to draw these like my stupid arrows for distributive property. And I'll show you why here in just a minute. So x times x, that's going to give me x squared. I'm just going to go down here and put it there. And outside terms, imagine that the middle between the parentheses is the row on seats of buses. So the outside, those would be kind of the window seats. That's going to be x times negative 2, which is going to be negative 2x. Okay, the inside, that's going to be the inside ones right on the row. That's going to be plus 4x. And then last, or the last two remaining, we can connect. And that's 4 times negative 2, which gives us negative 8. Now, one of the reasons I like this one the best is because my like terms are in the middle with each other. And my outside terms don't have anything in common. So that's x squared plus 2x minus 8. And you will see as we rewind, we've got the exact same answer. So it just depends on which method you like best. Now, I kind of like this method a little as well, because if you look at this, it's kind of like a little smiley man, and that's how I learned it, was connecting, and you've got got a little nose there in the middle, got a big smiley face underneath it. So again, completely your preference, whichever one you like. It does not matter to me. Now, we will get to some where we have a binomial times a trinomial. In this case, FOIL does not work. FOIL only works when it's binomial times binomial. So in this case, you would want to do the distributive property. So we're going to take x times 2x squared minus 4x plus 6. And then we're going to take 6 times 2x squared minus 4x plus 6. This would be a good opportunity for you to hit pause, go ahead and go through and do that distributive property, and then combine all your like terms in the end, and let's see what we get. Okay, and we're back. So here we go. We're going to get x times 2x squared. Remember, that's a 1x if you want to draw it there. That's going to give me 2x to the third power. Again, we've got that exponent that's there. Like bases, we add the exponents. It goes from chapter 6. Then we have 1x times negative 4x. So that's negative 4x squared. Then we have 1x times 6. That's going to give me positive 6x. We go to the second one. And we have 6 times 2x squared. That's going to give me 12x squared. We have 6 times negative 4x. That's going to give me negative 24x. And then we have 6 times 6. That's going to give me positive 36. All right, so let's get to a big piece of board here. Let's go with like terms. We have got only one that's to the third power. Then we have 2 that are to the second power. Then we have 2 that are to the first power. And then my final color is just my number. So let's combine all of those like terms. We're going to start with 2x cubed. It was the only one to the third power. Now we have negative 4x squared plus 12x squared. That's going to give me 8x squared. Then we have positive 6x minus 24x. So that's going to give me negative 18x. And then finally we have that 36. And so if they ask you on that one what the degree was, that would have a degree of 3. I don't think they're going to ask that, but just in case. Okay, so we've multiplied binomials using the FOIL method. We've multiplied binomials using the distributive property. And we've also multiplied a binomial times a trinomial using the distributive property. Now, obviously, you could multiply trinomials times trinomials, also using only the distributive property on that one. So that's a little over 9 minutes, 7-2, multiplying polynomials.